Alright, so what we want to do on this one is to be able to write it as a sum, and we want to see what is staying constant, and we see that the ones are actually appearing in every single term of the sum, and we also see that the fives are happening in every term of the sum. So we can write this sum as 1 over 5, and then what we see the number in the parentheses is the one that is changing, so we can say that this is I, the index I, and we have to see we're going from where to where. Well, we are going from I equals 1 all the way to I equals 11. Alright, this one is very similar. We need to see what is staying constant, so we write the sum from I equals to something. So we need to see what is staying the same. So we see that 9, it's appearing in every single term, and also the ones. And now we can have that is 9 over 1 plus, and then we notice that the other term, the other number is the one that's changing, so it is I. So it's changing every single term, and we go from 1 all the way to 14 on this one. All right. So next one. So this one is the same thing. So we need to see the structure of what each term looks like. So it's going to be the summation from I is equal to, and then we see what the structure is going to happen. Sorry, I made a mistake here. And now I'm going to rewrite it as sigma. Let's use a different index notation. I wanted to use k, but this looks like an r. From k equals 1 all the way to something, and then we write the brackets of 7, and we notice that all of them have parentheses, and we see that the 6 is on the bottom in all of them, and then we see that the 5 is added, we close the parentheses, and then we write k, since it's a place where it seems to be changing in every single one. All right, so now we need to see that go from 1 to 6. Yeah, sorry. Number 10. So again, same thing. So we notice that there is the sigma of I equals 1. The structure is equal to 1 minus, we notice that the parentheses, all of them have the 4 under. So it's something over 4 squared, close your brackets, and we go from 1 all the way to 4. 4. There you go. And now this one is a little bit more interesting. So we start looking and seeing here, and we want to see what's happening from the first term all the way to the very last term on this one. And let's see, we notice that they is going to be the sum of, well, let's see. We start with, we notice that all of them have that 2 over n. And now this one, what else? We're going from j, we're going to use a different variable. J is equal to, let's see, this is 2 over n to the cube power minus 2 to the n. And we notice that at the very end we have 2 times n over n to the third power. And on the other one, we have 2 times n over n. So that must mean that on the last term, this is where it happened. Now see, like, is this the first one? So it's 2 times 1 is 2 over n. And then the other one is 2 times 1, which is 2. So we do have the same one. All right. So there you go. So 2 times 1 cube. So then pretty much the 2 is staying constant, and then it's getting multiplied by the index j in this case. So we can actually go ahead and write this sum as a sum of, sorry. Eventually I'll learn how to edit these mistakes, but for now, just deal with it. Sorry. I'll get better at it. All right. So let's see. 2 times j, sorry, that's a j, cube minus 2 times j over n, and we're going from j equals 1 all the way to j equals n. All right, and since you see the 2 over n is going to be a constant in every single term, we can actually factor it out. And we say that this is 2 over n times the sum from j equals 1 to n of this whole thing here. 2j over n minus, quantity cube minus 2j over n, close your brackets. All right. This one is extremely similar. All right, so we notice that the two staying the same is brackets. We notice that the first term and the last term now. The first one is only 3, the last one is 3 times n. Maybe this is 3 times 1. And then 3 times 2, and then it's 3 times 3, all the way to 3 times n. And notice all of them have that 3 over n, so that means that that 3 over n is just being multiplied on every single term of the sum. So this is the sum, sigma from, let's see, we can use j as the index, from j equals 1 all the way to n. And we notice that the 3 over n, so we can factor it out. I just said 3. The 3 over n times 2, the parenthesis of 2 times 1 plus 3 times j over, let's see, let's do this one again, 3 times j over n. There you go. And then let's quantity square, and let's close the brackets, and that is the rewritten part. So if you enjoyed the video, I hope you did. There are other videos for you to watch. So yeah, have a good one.